Okay, ladies and gentlemen, we're going to go over part 5 of the final exam review, comparing functions. At this point, hopefully you've already gone over these problems, so you're just trying to check for correct answers. If not, then perhaps going through this video while you go over the problems or look at the problems will help adequately prepare you for your exam. So in number 1, we want to compare the end behavior for each of the following. Remember, the end behavior addresses what are our y values doing as we move to the left or to the right on a particular graph. So here we have two functions. We have a graphical representation of what appears to be a cubic function, and then we have an equation for what is a higher order polynomial. The leading, in this case, is you got a highest exponent of 6. So if we look at graph 1 first, what we're trying to figure out is if we trace this function as we go this direction, keep in mind that this function is going down and to the left. We want to know, okay, as x is approaching negative infinity, what are our y values or our f of x values doing? In this case, they are going down. So for this graph, as x approaches negative infinity, f of x is approaching negative infinity as well. And if we go to the right, we notice that as x approaches positive infinity, f of x is also approaching positive infinity. So we know that in our answer choices, we are looking for this description of function 1's end behavior. Now, looking at function 2, it may not be immediately obvious to you, but you notice that we've underlined this negative 2x to the 6th because the 6 is our highest exponent, making negative 2 our leading coefficient, which gives us some indication as to how or what the end behavior of our function would be. The easiest way to do this, however, would be to use Desmos or your graphing calculator to simply graph this function and then look at the end behavior. And you can see that as we trace this function going to the left, so as x approaches negative infinity, f of x is also approaching negative infinity. But we also see that as we move to the right, or as x approaches positive infinity, f of x is also approaching negative infinity. So what we have here is a situation where D is the correct answer. For function 1, the end behavior is as x approaches negative infinity, f of x approaches negative infinity, and as x approaches positive infinity, f of x approaches positive infinity. And for 2, the end behavior is as x approaches negative infinity, f of x approaches negative infinity, and as x approaches positive infinity, f of x also approaches negative infinity. Okay? So that's number 1. Number 2, here we want to compare the rate of change for both the yellow and red cars. Keep in mind, remember from Algebra 1 that a rate of change is simply the slope of a line between 2 points on a graph or on a function. So you want to take the first point and the last point in these particular cases and find the slope. That's all you're doing. So here, remember that this column represents your y values. This column represents your x values. You might want to go and review what the slope formula is. I will tell you verbally that it is y2 minus y1 over x2 minus x1. And that's what we have here. So these are your y values. These are your x values in the case of this chart. And here on this graph, this discrete graph, we have, these, your x values are a number of laps, and your y value, your time in seconds. So what we have here is we take the 4.6, and we subtract from that the 1.1, and we put that over the 5, which is the associated number of laps with the 4.6, minus the 1, which is the associated number of laps with the 1.1, and you end up with 0.875. You do the same thing for the red car, you end up with 0.825. Now, you need to be careful here. Notice that you have two answer choices, that give you 8.7 or 0.875 for the yellow car and 0.825 for the red car. However, the difference that you need to take account of is the units. For C, it is seconds per lap. For D, it's laps per second. Now, what is our numerator for our slope? The numerator is the time, which means seconds is in the numerator. Our denominator is laps, which means laps is in our denominator. So seconds per lap. That's why C is the correct answer and not D. Number 3, compare the following by determining whether they represent an odd function, an even function, or neither. An odd function, an even function, or neither. All right. So if you took the time to go over the videos, they very clearly kind of pointed out what you should or what the criteria were for odd functions or even functions. Okay. So if we look at function number 1, what we want to do here. All right. So for number 3, we want to compare the following by determining whether they represent an odd function, even function, or neither. I'm going to start with function number 2. Function number 2, in this particular case, it's very easy to tell whether or not this is an even function. Even functions are those which are symmetric across the y-axis, meaning that if I were to take a piece of paper with this graph and fold it along the y-axis, that the left side of the y-axis would lie on top of the right side of the y-axis. You can see pretty clearly here that would be the case. So we do know, or we can see, that function 2 is an odd function, or an even function, excuse me. Function 2 is an even function. For function 1 is given to you in an equation form, so you got to be a little bit more mindful as you approach this. So the rule for an odd function is that f of negative x has to be equal to negative f of x. Well, you don't need numbers to do this. What you can do is, as the rule states, you can, everywhere you see an x, replace that x with negative x. All right. What you got to remember is kind of your law of exponents. Remember that when you have an odd function, if you have, or excuse me, an odd exponent rather, you've got an odd exponent and you're raising a negative number, in this case, which is a negative variable, to a negative exponent, then that exponent will remain negative. So that's why we can move the 7 from here to inside the parentheses. Okay, so negative x raised to the 7th is just negative x to the 7th. And a negative times a negative gives you a positive, which is why this becomes 4x to the 7th. Same thing here. X to the 5th is still going to give you negative x to the 5th. And negative x to the 5th times a negative will give you positive x to the 5th. Same thing here, giving you now, in this case, 8 is positive, so you've got negative x cubed times a positive 8, which will give you a negative 8x cubed. So then what we can do here, remember, we're trying to get to negative f of x. So if we factor out a negative from all of these, we factor out a negative from these terms right here, we end up back where we started, which is negative 4x to the 7th, negative x to the 5th, plus 8x cubed, which is our original function. And remember, we factored out a negative, so we've got a negative in front of it. So this is f of x, and we've got a negative in front of it, so now we have negative f of x. So we have confirmed that this function is in fact odd. So B would be your correct answer there. Number 4, compare the following by determining whether they represent an odd function, even function, or neither. So now we're looking at a graphical representation. Now, upon first glance, a lot of people would say to themselves, oh, well, this is an odd function. It looks like a cubic function, but actually it's a an odd function that has been translated. Okay, so in order for a graph like this to be odd, it must be symmetric around the origin. Basically, when you say something is symmetric around the origin, it means that you can take a coordinate, for example, this coordinate right here, if it's symmetric about the origin, if you reverse the x and the y, you should get another point that lies on this graph. Okay? So if you reverse this x and this y and you don't get a point that is on this graph, so if we say here this would be 1, this would be negative 1.5 comma 0. So I should be able to go to 0 comma 1.5 and find that point on my graph. That doesn't happen. So it's not an odd function. I cannot fold it across the y-axis to make it symmetric around that. So it's not an even function, so it's neither. In the case of the even function, you can do that a number of ways. With this equation, again, you're just trying to make sure that when you plug in negative x, you still get f of x as an answer. So you can see here when I plug in negative x, a negative number raised to a positive exponent will give you a negative number raised to an even exponent will give you a positive number. Let me say it again. A negative number raised to an even exponent will give you a positive number. So because of that, negative x to the fourth becomes just positive x to the fourth, giving you 5x to the fourth. Negative x squared gives you positive x squared. Or excuse me, I'm sorry. Negative, and this right here needs to be corrected. So this should have been negative x squared would give you positive x squared, and then a positive x squared and a negative would give you negative x squared right here. And then you have your 4. So just please excuse this mistake right here. I forgot to fix this. But this should be a negative. Again, negative x squared will give you positive x, and positive x with a negative right here would maintain a negative. So that should be a minus sign right here. But when you plug in negative x, you still have with f of x, which is your original function. So this makes this even. So your answer is f. I is neither even nor odd, but or function 1 is neither even nor odd. Function 2 is even. Number 5, which of the following functions are increasing over the interval negative infinity to positive infinity? Remember, we're saying it's got to be going up the entire time. If I start on this side of the graph and trace to this one, my y values have to be going up the entire time. Well, you can look at functions 2 and 3 and see immediately that that's not happening. This one's going down the entire time as I move from left to right. This one starts off going down from left to right and then goes up. But if you look here, you can see these are my negative values. So I'm going up along the number line, and you can see these values are going up as well. So this one is increasing over the interval. And then this is the equation for a line that's going up from left to right. It's got a positive slope. You can see it's got a positive slope of 3, which means it's increasing the entire time. So functions 1 and function 4 are increasing over the interval of negative infinity to positive infinity. Last one says just determine the x and y intercepts of the following functions. These are fairly straightforward. Remember that when you're looking for the x-intercept, you're looking for the place where y equals 0. And for your y-intercept, you're looking for the place where x equals 0. Or you're crossing the x-axis, and vice versa. On the y-intercept in graphical form, you're looking for the place where your graph crosses the y-axis, and then you identify the coordinate appropriately, as has been done here. If you have any additional questions, please reach out to your designated instructor. Thank you.